Okay, so the main thing with stoichiometry here, just like with the rocket lab that's due today, hopefully you turn that in, is, it tells us kind of not only what needs to go in so that we get a perfect reaction, but it also tells us what's going to come out of the reaction. So remember when we looked at the different ratios, we said, yeah, that 4:2 ratio was perfect. And we can tell that by looking at the recipe. So, really our balanced equation is just that. It's a recipe. So we can use that recipe to figure out how much needs to go in or how much is going to come out. So when we look at 1A there, what type of a reaction do we have there? I see we've got a compound. We've got another compound. So that's going to be a double displacement reaction. And when we look at the 1B there, it says that how many grams of CaOH, how many grams of CaOH, calcium hydroxide, and I'm just gonna put a box around that, and you should do that as well on your sheet, because that's what the problem's asking. We're trying to figure out this CaOH, and we want to know how many grams of that can be made if we react 64 grams of this CaC2. So I'm going to put a box around that as well. And I'm just going to, above that, write 64 grams. So I know I have 64 grams of that CaC2. How much of that CaOH can I make? So we can use stoichiometry to tell us just how much CaOH will be produced. Okay? This last part, I don't want you to worry about a whole lot. It says in excess of H2O. What that means is that we're not going to run out of H2O. If we were to run out of it, just like you saw in the rocket lab, the reaction would stop early, right? So that's all that says. Don't worry about that right now. We'll get into that next week. So you can either cross that off or just ignore it, okay? So when we do a stoichiometry problem, we always write down what the problem gives us to start. So this problem is telling us that we're starting with 64 grams and then put a label on it, CaC2. Sorry, my handwriting's not that great on an iPad. Then I'm going to make a T-chart. You should be able to, at this point, change that from grams to moles. If I add this up here, maybe in the margins, calcium's about 40.1, I think. 2 carbons, 12 apiece is 24. I'm getting that off the periodic table. So that ends up being 64.1 grams of CaC2. And that's 1 mole, right? That's off the table. The table's all 1 mole. Again, should be review. This next part is actually the part that's brand new, all right? So converting from one thing to the next. When I do that conversion from one thing to the next, I'm going to look and I'm going to use my recipe, right? If I look at my recipe, for every, well, there's no number in front of this, so it has to be a 1. For every 1 part CaOH, it looks like I have 1 part CaC2. So for every 1 mole of CaC2, I get 1 mole of CaOH2. So what I did there was I was able to convert it from one thing to the next. I can use those coefficients kind of like a bridge. My last step, you can see there's quite a few parts of this, but most of it should be revealed. My last step is going to be to go from moles of that CaOH, so 1 mole of CaOH, again, review. I have to add this up. Calcium is 40.1, plus 2 oxygens is 32, plus 2 to give me my molar mass of, 74.1. grams of CaOH2. Okay, so now it's just a matter of punching this into the calculator. I'm going to take 64 here, divided by 64.1. You can mess with the ones if you want. Multiply by 1, divide by 1. You're going to get the same answer. Times 74.1. When we punch that into the calculator, what we get is 73.9 grams. Always have a unit. Oh my gosh, my handwriting's going. CaOH2. Okay, sorry about that last part. Got away from me. So what I want you to do is I want you to pause the video. I want you to try 1C. And when you do 1C, what we're going to look at is almost like we're starting over. If you look at what the problem for 1C says, I'm going to erase this so it's brand new. For 1C, if we pull that information out of the problem, it says we've got 132 grams of water. And so since I just started over here, I'm going to put a new box around it. 132 grams of water. How many grams of C2H2 can I make? Okay, so we can literally convert from one thing to the next, no matter if we're looking at reactants to products, reactants to reactants. So give that a shot. Okay, so I'm going to take 132 grams of water, H2O, and hopefully you added those up. So oxygen is 16 plus 2 for hydrogen, so 18 grams is 1 mole of water. Now the new thing with this is that it's not a 1-to-1 ratio. So the thing that's new here is that if we look at our coefficients here, the number in front of water isn't 1, it's actually a 2. So for every 2 moles, that 2 is going to go on the bottom because I need moles of water to cancel. 2 moles of H2O, I'm going to have 1 mole. That number in front of C2H2 is still 1. I'm going to have 1 mole of C2H2. All right? And now again, we do another moles to grams. So 1 mole of C2H2 weighs, let's see, 2 carbons is 24 plus 2 is 26 grams. C2H2. And when we punch that into our calculator, we get 95.3. Make sure you have a unit on there. Grams of C2H2. All right, go ahead and try number 3 for tomorrow or Monday, and we'll see you then.